Okay, this is the P4 paper from January 2024. This is question number 3, and if I show you it in its entirety, this is a differentiation question, and in particular, this is differentiation of parametric functions. So let's just have a look at it, and it says we've got this curve C, which is defined by y squared x plus 3y is equal to 4x squared plus k, and that's where y is going to be greater than 0. K is equal to a constant. Part A is not too bad. It says, can we find dy by dx in terms of x and y? So yeah, we'll go ahead and do that in a second. And then part B starts talking about the minimum point P there, and that will enable us to work out what P and K are. But let's focus on the first part. So the first part says, we've got this function then, y squared x plus 3y is equal to 4x squared plus k. Let's just have a quick look at it. The first term there, then differentiating that, I'm going to need to differentiate it as a product. I'm going to need to call this u and this v, and then do the idea that it's u dv by dx plus v du by dx. The rest of it, we should be okay just to differentiate. So it's up to you how quickly or slowly you want to do these. What I'm doing on the videos is to try and encourage you to do it at a reasonable speed, simply because we are P4 students now. So if I'm going to do this, if you want to, and you want to write down u dv by dx plus v du by dx and take your time and get it all absolutely 100%, that's fine. I'm going to do that without writing it down. So u dv dx, u is y squared, dv dx is the differential of x, which is just 1, plus v du dx, well v is x, du by dx then is the differential of y squared, and this is where we first start introducing parametric differentiation. Differential of y squared multiplied by the power, take 1 off the power, so 2y, but obviously every time we have a y function, we have to make sure we include dy by dx. That's all of that first term done. Everything else should be pretty straightforward. Differential of 3y is 3 dy dx. The differential of 4x squared is 8x, and the differential of k will disappear. So this is pretty standard. Let's tidy this up before we get dy by dx. That's y squared, 2xy dy dx. That's 3 dy dx is equal to 8x. Let's get the dy by dx is onto one side. So in other words, swap that y squared over. We're going to get 2xy dy dx plus 3 dy dx is going to be equal to 8x minus y squared. Let's factorize and take dy by dx out as a factor, which gives me 2xy plus 3, that's equal to 8x minus y squared, and so dy by dx then is equal to 8x minus y squared, all divided by 2xy plus 3. So if we go back, part A said just can we find dy by dx. So yeah, we managed to do that. Part B, let's have a look at it. It says point P, which is P2, coordinates of this are P2, is the minimum turning point. Well, if it's the minimum turning point, we know the minimum turning point happens when dy by dx equals 0. It happens when the gradient is equal to 0 there. So what I'll do is I'll do dy by dx, which we've already got. If I put in P2, those two values, I know the function's going to work out to be equal to 0, and that should be able to give me enough information to work out P and to work out K. So let's just make it clear to the examiner then. Part B part 1, because we're going to be trying to find P first of all, I think it is. So if P is a minimum, then dy by dx is equal to 0. So dy by dx is what we've just worked out, 8x minus y squared all over 2xy plus 3. That's going to equal 0, but we also know that's for the value x is equal to p and y is equal to 2. So if I put that in, I'm going to get 8p minus 2 squared over 2p times 2 plus 3, that works out to be equal to 0. So in other words, 8p minus 4 as the numerator over 4p plus 3, doesn't matter what the denominator is, if that's equal to 0, then it has to be that 8p minus 4 equals 0, which means that p is going to work out to be equal to a half. So we've managed to find that. So we now know that p is equal to a half. So for part 2, p is actually then the points, instead of it being p2, is actually the point half 2. So if that's true, we can put that into our original equation. So let's just quote our original equation again, which was y squared x plus 3y is equal to 4x squared plus k. But I know that x being equal to a half and y being equal to 2 satisfies that. So it's 2 squared times a half plus 3 lots of 2 is equal to 4 lots of a half squared plus k. This works out to be 8 is equal to 1 plus k. So in other words, k is going to be equal to 7. Right, okay, so hopefully that all makes sense to you. A fairly straightforward question.